All right, in this last objective of AP Calculus, we're going to learn about slope fields. A slope field is a way to draw a picture using a differential equation. Um, and what it does is it shows what the original function looked like without integrating. So it's basically a technique of going backwards without actually doing an integral. So before we start, I put on your page um, a couple of slopes here. So you see 7 dots and 7 slopes that I want us to sketch. And the reason I'm doing this is the purpose of a slope field is to draw little sketches. So a slope of 0, you know, is a flat line. So that one should be easy. Through that first dot, just a little flat line. Notice that I center the line in the center of that dot so it goes both left and right. Now, everything else about this, I know you know what these slopes are, is just a technique to sketch them quickly. So a slope of 1, the next dot, means that you would go up 1 over 1. That means you would go to that point. So when I draw a little line in my slope field, I draw a line that kind of points at that point. A slope of 2 would go up 2 over 1. So that's up here. So I'm going to draw a line that kind of points up 2 and over 1. It's pointing at that point. You notice it's steeper than this. This is just an easy way to draw short little slopes without having to do a lot of work. A slope of 1/2 would be up 1 over 2, so that would be that point over there. So I'm drawing a short little line, excuse me, that's pointing at that dot. Up 3 over 1, up 1, 2, 3. I know this is off the page, but it's like up there. It should be steeper than 2. -1 points down 1 over 1, and then -2 points down 2 over 1. Basically, you just want to be quick and good at this. It'll make your life easier. As you can tell, this objective is very much a drawing objective. I probably should have said this at the top of the video. If you can print this, great. If not, when you get to the actual practice, you'll see that the graphs you have to draw are very easy graphs. So so don't worry about it if you don't have access to a printer. All right. In the example, it says, plot the slope field for this differential equation. dy dx is equal to x over y at the 10 points indicated. So this is a common way that they ask it on the AP exam. 10 is actually usually a little bit more than they ask. But if you notice on this graph, there's 20 points. Every dot is an indicated point, 1, 2, 3, 4, 5, and then there's 4 such rows. There are not dots on the axis, on the x-axis, but there are dots on the y-axis. This is important. They do not ask you about undefined slopes, and the dots on the x-axis would have been undefined slopes. So everything I'm about to say I explain here so you can read it too. You take 1 point at a time, and you just find out what the slope is. So this point right here is the point -1, 1. And if you put -1, 1 into this expression, you get -1 over 1, which is -1. So that little slope is a slope of -1. This point here is -1, 2. So if you put -1, 2 into that expression, you get -1/2. So that slope is -1/2. We're going to continue this for everything else. So this point right here is the point -2, 1. So -2 over 1 is -2. So that point should have a slope of -2. This point up here is the point -2, 2. So -2 over 2 is going to have a slope of -1, same as this one. So that slope is -1. Look at these 2 points on the axis here. These both have an x value of 0 with different y values. Well, think about what that means. If there's a 0 on top, it doesn't matter what the number is. That means that right here and right here, these points are going to have a slope of 0. And in fact, even these two down here are going to have a slope of 0, because any point that has an x value of 0 is going to come out to 0. You notice that that I just noticed a pattern so I can make my life easier. I'm going to recommend you look for patterns as much as possible when you do these. In the first quadrant, 1, 1. 1 divided by 1 is 1. 2 divided by 2 is also 1. Well, that means that this is also going to be negative 1 divided by negative 1. That's 1. That's going to be 1. These are going to be negative 1. This point over here is 2, 1. So 2 divided by 1 is 2. There's a slope of 2. This point up here is 1, 2. So 1 divided by 2 is 1/2. And this looks like a mirror image of that. So I've noticed a pattern. There won't always be a pattern to find, but there was in this case. This point down here is 2, negative 1. So that's going to be negative 2. This is 1, negative 2. So that's negative 1/2. And this is a mirror image of what's above, which means I can probably fill this in. This is going to be positive 2 and positive 1/2. So that's the slope field. We couldn't do it on the y-axis. We did it for 20 points. Usually in the AP exam, they only actually ask you for like 8 points or 10 points, or sometimes even only like 6 points. The next section, I put a couple of matching in here to show you some nuance. What I want you to notice here is that we've got slope fields that have the same slope for entire rows or columns, and I want you to see why that is. So look at A. Do you see how this has a slope of 0 for that entire row? What do you know is true about every point in that row? Does it have the same x or the same y? Well, it has the same y in different x's. What that means is that the differential equation that it came from must only have a y in it. Because if the x changes, but the slope doesn't change, then that meant that x had nothing to do with it. So A is going to be 3. And you can even see this, like we chose a slope of 0, 2 minus y. Well, if y is 2, then that slope comes out to 0. And sure enough, up here at 2, we have a slope of zeros. Look at B. This has a column of zeros. So m equals 0 here at the same x. And what x value is this? Well, it kind of looks like x equals 0. Which one of these would be 0 for every x value where the y doesn't matter because they're not changing? Clearly not 2. It could be 1 because sine of 0 is 0, or it could be 4 because if x is 0, then it's 0. I'm looking ahead. I can see that that's going to be the sine 1. So this is going to be B. Here's our sine 1 here. You notice it's all the slopes in the column are the same, so it's only going to have an x, and then it follows that sinusoidal pattern. And then this one's going to be D, and you can even check this out. I recommend looking at the zeros. Do you see how those zeros seem to occur at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4? Well, that means they occur whenever x and y are the same. And sure, in this case, like 1 minus 1, 2 minus 2, 3 minus 3, and so on. And then second section of matching. We've got a few more that are like this. So let's see. Here's an example where all the y values, the slope is 0 whenever y is 0. Well, let's see. That wouldn't happen there because y is not in it. That could happen there. And that wouldn't happen in either of these because these have x's in them too, so it must change. So this is G.
My A and my B and my
Avi, you had to promise not to be quiet while I did this. Here's a problem where the slope is 0 whenever x is, I don't know, it looks like maybe 2 or something, but certainly above in like a low positive number. Well, that's going to have to be this one because both of these have both x's and y's. 2 turned out to be a decent guess because 0.5 times 2 minus 1 is 0, but really just it shows that some small positive number would give you 0 just for x's. Here's an example where it looks like all the 0 slopes are when x and y are the same except one is negative. So that looks like this. If x and y are the same but one is negative, that'll come out to 0. And here's a case that's similar to the one that we did by hand. It kind of looks like a circle, but I don't know, there's different ways to do this. Do you notice how everything in the first quadrant is negative? Well, if you put in everything in the first quadrant has a positive x and a positive y, well, a positive over positive is positive, but with a negative out front, that's negative. That's opposite in this quadrant. See how this quadrant, all those slopes are positive? Well, that's because there's a positive negative, and with the negative that's already there, the slope would come out positive, and that's what that shows. So you can also look at the direction of the lines, if that would help. So this is H. The last thing about this, and they do sometimes ask this, is sometimes you have to draw the function using an initial condition that went through a slope field. When you do this, so here's a slope field. They gave you an initial condition. That condition
What
is...
are other
Oh
conditions?
no, you had a promise not to talk. Yeah. All right. The initial condition here is 1, 1. It's a little hard to see, but 1, 1 is right
What
there.
are those colors?
Avi, for me to draw with. Um, so what you do is you draw a line that follows the contours of the slope field. So like in this case, I wouldn't draw a line that goes just like down left because that cuts across all these lines. You kind of have to follow things. So as you draw a line, you try to follow the arrows as much as possible without like crossing any of them. And you can kind of tell that this one should make a circle. It looked like a circle anyway, but the differential equation that gave you this with this initial condition shows you this. If I had given you an a different initial condition, like right there, you notice it still would have made that shape, but it would have just been a different circle. This is a different circle than the one above. In this second example, -1, 0.5 is right there. I know these graphs are a little bit weird. And do you see how this kind of just looks like it has a bump? The reason I put this one in here is I want you to notice that there's an asymptote in the middle. And the reason I put this in is that sometimes when you draw these on the AP test, you have to avoid asymptotes. So when we get down here, we're not going to cross to the other side. You can see that there's an asymptote. It's not going to cross it. So I'm going to draw on the line. I'm going to go both left and right. This one's not going to come back. And this just kind of looks like, I don't know, like a little bump. It's going to have an asymptote on both sides. You can kind of see that's what it looked like. The reason that I put this in is, the reason that I put this type of question in is that they ask it on the AP exam actually kind of often. However, because the AP exam this year is not going to have is going to be you do it at home, I'm a little skeptical that they're going to give you graphs that you have to draw. So I think it's unlikely that slope fields come up on this year's exam. However, it is in the content that they said is going to be on the exam. So that is it. That is the last objective of AP Calculus, and you actually learned every single objective. So whether or not everyone else did, you can go to college knowing you learned all of calculus.